What is light? Why does light come in different colors? Why do some things fall faster than others? Why do things fall at all? What is weight? What is mass? Why can't I fly? What are we made of? How fast is this guy running?
What is sound?
All of these profound inquiries constitute the composite question of how does nature work? We do not truly know, but trying to understand the little things we experience around us, like light and sound, may ultimately lead us to answering the question to how nature works. Or, by the way, if you want to sound fancy, you can reword this question to what are the laws that govern nature? I hope you care about answering this question, because if you know the answer, you'll know what the universe police will do to you if you ever break the laws of nature. Welcome to the Unreal Junkyard. My name is Mustufa Gamma, and this is the outset of Physics 101, a 10-episode long journey into the realm of physics. Join me on this adventure for the ages. For millennia, we human beings have tried to ascertain the underlying principles of our universe. And although we have answered the whys and hows of many natural phenomena, as of yet, we cannot completely explain what we witness. But we're trying, and science is and has been by far our best guide to trying to understand nature. So, students, how does nature work? Do any of you have an answer? Philosophy? No? Math? Maybe? Science? Go on. Yeah, so the answer to how nature works is, out of the different sciences, physics is the most fundamental, broad science. What is physics? Well, it's kind of hard to state a definitive answer, but you can think of physics as the most accurate model we have to explain what we observe in nature. But it's a very incomplete model. That's why it's also a method with which we're currently in the process of creating models to help us explain nature. There are indeed humans out there trying to answer crazy questions using physics. They're called physicists. These are scientists who are doing some pretty cool stuff. Roughly speaking, there are two cardinal types of physicists: theoretical physicists, theorists, and experimental physicists, experimentalists. Theorists are the people who discover new laws and theories of nature. Experimentalists are the ones who test the validity of those theories by pushing them to their limits through conducting experiments. Physics is an experimental science. If there are any anomalies found in experimental data which cannot be explained by existing theories, the theorists reform or completely discard their theories. Their newly updated and crafted theories are then retested through experimentation. The theorist and experimentalist have a symbiotic relationship, wherein the experimentalist is given the theories to test, and the theorist is given data to work with and predicate further theories on. This method of doing science is called the scientific method, and it has been extraordinarily effective in guiding us to gain a respectable understanding of our universe. By the way, what is the difference between a law and a theory? A theory is a well-proven explanation for the patterns of nature, whereas a law is a concise description to describe a pattern, often depicted as an equation. Laws are undeniable because they are absolutely necessary to experimental data, but theories may or may not be accepted depending on their compliance with data and other factors. Physics has helped us humans become the masters of our Earth. The artificial world we've built is a vast manifestation of our sophisticated understanding of the physical laws that govern nature. and that is to be expected. Scientific and technical innovation is an inevitable consequence of trying to understand the natural world and its laws. When we understand something that we see, we apply our understanding and harness nature's elements for our own betterment. Physics is the study of our universe at the most fundamental level. Through physics, we can make educated guesses and predictions and model systems using math. Wait. Don't leave, please. I promise physics is not just... Really, it's about choosing the right maths that any situation at hand demands. We can do just that by, for example, formulating an equation explaining the certain system that we are concerned with. A system here just means the chunk of the universe that we are studying. I've got this pot of half a liter of water, and I cannot, with any respectable degree of accuracy, discern how long it will take all of this water to turn into steam if I heat it from a fire from this guy. Say hi to thermodynamics. He's a friend of mine. But if we use the mathematical equations of specific heat capacity, we can calculate that it will take just around 479 hours for all this water to turn into steam. Dude, thermodynamics, your flame is so weak. Maths helps keep physics unambiguous, honest, quantifiable, calculable, precise, and definitive. Pick whatever word you fancy. You get the point. I alluded to the vastness of physics earlier. Testament to this is the myriad of subfields in physics. We have classical physics, astrophysics, condensed matter physics, particle physics, and so much more. But for our purposes, we will focus on classical physics. So, why take the classical route? Well, classical physics is the most basic and original form of physics, and it makes sense to start from the very beginnings of physics, right? Classical physics was pioneered hundreds of years ago by compelling physicists like Sir Isaac Newton, Galileo Galilei, and Michael Faraday, amongst many others. In the late 1800s, a relatively low-profile guy named Albert Einstein came in and completely changed the game, and we'll talk about him a bit later, too. It was physicists like these that helped us go to the moon, create beautiful windmills, handheld devices, and also, unfortunately, nuclear bombs. Alongside physics, we will also venture into the world of philosophy. Yes, it sounds kind of extravagant and tasteless, but it's going to be awesome. Trust me. Physics has been around for thousands of years, and over its long life, it has taken many forms. Before the scientific revolution and the advent of classical physics, there was limited progress, but natural philosophy was basically the science of those days. At the time, philosophers like Aristotle and Socrates tried to develop their own answers to questions that they asked about our natural world. It was at this time that the first theories to explain nature were developed. However, they were quite baseless and mythological, hardly backed by any sizable empirical evidence, as we'll see in the coming episodes. Anyway, with a mere understanding of basic high school mathematics, you and I are going to wrestle with the Newtonian laws of motion and gravity, witness the weirdness of light and waves, stare into the blazing fire that is thermodynamics, and shock the realm of electromagnetism. However, please note that since this series spans less than a dozen episodes, each of these topics will be covered only in an introductory manner. One day, physics will be complete. Humanity will close this quest for meaning, and nature will be at our mercy. Probably. Maybe. I think. At least there's a chance.